Welcome. This is supplement to the comment I had posted, and here I'll show you calculations. So in the comment I had posted, I had shown how you would calculate the probability. So I showed how binomial distribution is applicable here, and again you may want to read through the chapter on probability distribution, the book by Sept and Zhang, which you have access to online if you choose. And here I explained that you can treat even and not even, that is an even number showing up or an odd number showing up, as two possibilities. They are mutually exclusive. That's, you can either get an even number or an odd number, and they're exhaustive. That means those are the only two possibilities. When you toss a die, either you would get even number, that is 2, 4 or 6, or you would get an odd number, which is 1, 3 and 5. And if we say probability of an even number is twice as likely as the probability of getting an odd number, therefore probability of getting an even number is 2p if the probability of getting an odd number is p. So if you add all the possibilities, that is probability of getting a 1, which is p, probability of getting a 2, which is 2p, and then again probability of getting a 3, which is p, probability of getting 4, which is 2p, probability of getting a 5, which is p, and then probability of getting a 6, which would be 2p, and all that combined would equal to 1. And if you equate the two, that is 9p equal to 1, that would give you p equals 1/9. So probability of getting an odd number would be 1/9, probability of getting a 1, another 1/9, probability of getting a 3, and another 1/9 probability of getting a 5, and that would be 3/9 or 1/3. Similarly, probability of getting an even number would be 2/3. So if you use these probabilities, how would you do the calculation? So let me go to the Excel spreadsheet. Here we start with, we again are starting with a biased coin. Probability of, say, even number coming up, which is similar to, say, you're tossing a coin. So suppose we say either head or tail. So head is, say, even number, and tail is odd number. So that gives you probability of head as 2/3, which is what I had entered, and that equals to 0.67. That's what you get. Now, to enter into the binomial distribution function, here we have number of successes, which is 5, number of tosses 15, probability of success, which is the same as what we had just calculated here, and in fact it's entered as equal to that number, and its cumulative is 0 because we are not calculating a cumulative probability. So if you enter that in the binomial distribution, and I have written that formula on the left. So this equals binom.dist, 5 number of successes, 15 number of trials, 2/3 probability of success, and 0. So if you calculate that, then you get that probability. Similarly, to calculate probability of getting 1, so again now you have either 1 turns up or 1 does not turn up. So you have two possibilities, that is 1 turns up, and when we say 1 is not turning up, that includes everything, 2, 3, 4, 5 and 6. Again we are calculating probability for 5 successes. Number of tosses is 15. I'll just correct that. And probability of success again is 0.1111, and binomial distribution, the again numbers are the same. Number of successes 5, number of tosses 15, probability of success here is 1/9. That is what we had just calculated here. And again, we are not calculating a cumulative number, so that gives us 0. Now, some of you had asked me how the probability could be higher for, you know, for getting 5 ones as compared to the even number, and that's the way your, you know, probability distribution is distributed. If you look at all the probabilities, so this is probability for you know, p being 1/9 or 0.1111, and then similarly you do get the distribution for 2/3 probability. So this is, you know, I've calculated the whole distribution, so you get probability binom dist. You have d3 as the number of successes, and 15 is fixed, which is your number of tosses, and then p-value is given in E2, and see I have put that $sign to anchor it so that when I copy it stays E2. And you know, same thing here, you would have F2 because that's where your probability is. And when you copy it down, say for example in 15 you have the same numbers like D18, that is where you have 15, the number of successes, and 15 tosses, probability E2, which is 0.1111, and non-cumulative. And when you graph these, this is the chart you get, and you can see that when your probability is 0.67, it looks more normal than it would, and we'll talk about that later on. But these are the two distributions, and I hope it answers question by I think at least a couple of you who are asking how is that happening. So I'll stop here, and if you have any questions, please post them in the question for instructor. Thank you.